Hello, I'm Tom Janicki. I'm with the Propane Education and Research Council out of Washington, D.C. Thank you for your interest in propane energy pod homes and in energy and environmental analysis. Bundles or collections of energy-related building systems in homes can form the basis for what we refer to as an energy pod or package. This bundle of 5 indoor energy applications, the propane energy pod, can be the foundation for homes delivering energy and CO2 emission savings that outperform typical new homes in the marketplace. Building energy analysis was used to evaluate the energy and environmental performance of propane energy pod homes. 2 prototype homes were used across different climate zones, and these results were compared with standard homes in featuring recent technology advancements. The propane energy pod home provides analysis-based content to establish propane as a whole house solution for energy efficiency, environmental performance, and comfort. A truly energy efficient, carbon-friendly home with high-performance systems and appliances is no longer something that only die-hard, back-to-earth types are searching for. According to one homeowner survey, 87% of respondents said they plan to have high-efficiency heating and cooling systems in their next homes. 86% said those homes would include high-efficiency appliances. In other words, nearly all consumers now place a high value on efficient and eco-friendly home energy solutions. A home's energy profile should be efficient at all points of use. That's the goal of the propane energy pod, a model for new home construction that treats 5 applications of propane: space heating, water heating, cooking, clothes drying, and fireplaces as components of an integrated whole home energy package. By treating these 5 highly marketable parts of a new home as a whole, the propane energy pod illustrates the full impact of propane-enabled homes. The propane energy pod brings a collective benefit of whole house comfort, convenience, and performance to the home as a whole package. Here we see specific examples of advantages of the pod in terms of whole house comfort and performance, as well as the energy savings which are experienced throughout the years from these 5 applications. Pods also offer a lighter carbon footprint compared to an all-electric home or homes using heating oil and electric systems. Propane's versatility also provides the homeowner's choice in how they use and change their home over time. Here we see just a couple of examples of how the pod offers flexibility now and in the future. As evidence of the propane energy pod's value, we see recognition within the industry. The standard method for rating the energy efficiency of homes clearly shows a scoring advantage for pod homes compared to standard all-electric homes. We'll see more information on that in a few minutes. Federal tax credits put dollars on the table, especially for builders of high-efficient new homes. Pods deliver much of the efficiency needed for a home to qualify for above-code programs. Finally, state and local incentives are often available for technologies within the pod. The research objectives were to develop climate-appropriate bundles of energy-efficient propane building systems, to analyze the energy and environmental performance benefits that are possible with bundles of high-performance propane-based building systems, and to evaluate these propane technology bundles or pods in typical homes as compared to standard technology and packages in those same homes. To accomplish these objectives, the researchers reviewed and analyzed the technical specifications of propane building systems, conducted energy modeling on prototype homes, and performed energy cost analysis. A detailed methodology was developed to guide this analysis of multiple building systems in prototype homes across multiple locations in the U.S. This methodology provided for a consistent approach to the analysis across the many variables which were involved. The backdrop for the energy simulations which were used to simulate propane energy pod technologies were 2 prototype homes. For each of the 16 analysis locations in this study, a production and a custom home were modeled. Both homes were single-family, detached, with a production home prototype at 2,400 square feet and a custom home prototype at 3,600 square feet of above-grade conditioned floor space. The custom home prototype varied slightly from the production home in areas such as zoning, where the custom home was assumed to have two space heating and cooling systems to cover a larger floor area. The characteristics of the two prototype homes were based on the following data sources: the U.S. Department of Energy Residential Energy Consumption Survey, commonly referred to as RECS, the 2009 International Building Code, and the U.S. Census Bureau. RECS and Census Bureau data were used to define and establish floor area, number of bedrooms, number of stories, and a foundation type based on location. Further, the building envelopes were designed to meet the standards of 2009 IECC. The Energy Code governs current residential construction practices related to the insulation and energy in much of the U.S. and therefore served as an appropriate reference for defining the prototypes. For each of the three climate zones, cold, moderate, and warm, a specific propane energy pod was developed. Each propane energy pod included a technology for space heating, water heating, cooking, clothes drying, and a fireplace. The specifications for the 5 technologies within each pod were based on current product offerings in the marketplace, as well as a climate for climate-sensitive applications such as space heating. For instance, in a cold climate pod, it made sense to specify a best-in-class 97% AFUE propane furnace. In milder areas, it made sense to hybrid a system incorporating a heat pump with high-efficiency propane furnace. Specifications also included other important system characteristics, including the system capacity, its efficiency, its flow rate in the case of water heating, and the unit design such as sealed combustion furnace, fireplace, or water heater. The research also included standard homes which were the exact same prototype homes as the pod homes, except that they used electric building systems for the 5 applications found in the pod. In the standard homes, electric baseline systems were specified, such as an air source heat pump for space heating and an electric storage tank water heater for water heating, as well as electric appliances for cooking, fireplaces, and clothes drying. These are typical systems found in many all-electric houses, and they represent a sort of baseline that we can use as a comparison point for the pod homes. One wrinkle for the standard home was in the Northeast, where the standard home used a heating oil furnace for space heating. This detail was built into the study to capture the fact that many homes in the Northeast still use heating oil as the energy. As a result, pod homes in New York and further into New England are compared to a standard home with a heating oil home heating system. In all cases, whether electric or heating oil components were used, the space and water heating systems in the standards homes were set at current federal standards. Again, this is typical in many new homes in the market. Monthly data from the U.S. Department of Energy's Energy Information Administration, EIA, was used to develop annual average energy prices for heating oil, electricity, and propane, and at a state level for each location analyzed. The 2010 calendar year data was used in developing prices. Heating oil prices are only presented for 2 states in the Northeast because heating oil systems were only considered as part of the baseline home in this section of the country. While calendar year data is looking back a couple of years at this point, in the 1 to 3 years since, propane prices have remained stable or dropped on average while heating prices have continued to increase. In all other areas, the baseline home was assumed to have an all-electric building system. It's important to understand that all energy-consuming systems in a home are tied to some form of CO2 emissions, unless they're powered directly or indirectly by an energy source with a zero CO2 emission, like solar power, hydropower, or nuclear power. For the vast majority of systems powered by electricity as well as propane or heating oil, there's some type of carbon footprint connected to the system's operation. For this research, the CO2 emissions associated with energy consumption were calculated using emissions factors sourced from the U.S. Environmental Protection Agency. The electricity emissions factors were sourced from EPA's eGrid 2012 at the state level for each location analyzed. These factors take into account the profile of how electricity in the state is generated, whether from coal-fired power plants, gas-fired, or other sources. Depending on the mix of power generation in a state, the emissions which are linked to every unit of electricity that's consumed in that state have some CO2 associated with it. Heating oil and propane emissions factors were also sourced from the EPA. While the state-level emissions factors were used to calculate CO2 emissions data for each analysis location, the average emissions factors used in the study are compiled in the chart above. A quick glance shows that the electricity used in homes carried a heavier CO2 impact for the same amount of electricity consumed. The charts in the following slides illustrate the whole house annual energy cost for both prototype homes, the 2,400 square foot and the 3,600 square foot, as equipped with a propane energy pod and the baseline equipment package. While there are 3 climate-based pods, the results are actually broken down into 4 climate-based categories. The cold climate region is separated into a cold northeast zone, where the baseline home was assumed to have a heating oil-fired furnace for space heating, and a cold Midwest and West zone, where the baseline home was all electric. This was done to more accurately reflect the marketplace and the fact that heating oil is a major factor for home heating in the Northeast. Moderate and warm climates are also represented. As the 2 bar graphs indicate, the annual whole house energy costs are lower for propane energy pod homes for both prototypes across all regions. Whole house energy cost is presented as opposed to just the energy cost for the 5 end uses in the pod, because whole house energy cost is generally a more meaningful number to industry professionals and homeowners. Further, the energy cost difference in each climate region are due exclusively to the 5 technologies contained in the pod: a furnace or hybrid heating system for space heating, a tankless water heater, and a propane-fired cooking, clothes drying, and fireplace. Other loads in the homes, like lighting, are equal across the pod homes and the baseline home. The difference in CO2 emissions associated with the pod and the baseline home is striking. This bar chart shows the CO2 emissions for each pod and the region for the 2,400 square foot home. The pod home has on average 24% lower CO2 emissions than the standard baseline home. The largest difference is in the cold climate pod for the Midwest and West. In this region, the baseline home relies upon an air source heat pump for the space heating. At colder outdoor temperatures, this system will rely on very inefficient electric resistance backup heating to maintain heating for the home. This results in a large amount of electric usage, which translates to heavier CO2 emissions, especially in a region like the Midwest, which relies on coal for the production of much of the electric power. The key conclusion of this research is that packages or bundles of high-performance propane-based building systems can be used by builders as an integrated energy approach to new home construction. They provide superior energy performance and related benefits. The research provides quantitative results that demonstrates that pods of this type outperform standard efficiency packages in terms of annual energy cost, CO2 emissions, and HERS index ratings. Note that this research didn't cover everything. For example, there isn't a quantitative analysis of the high performance benefits of the pod technologies, like the tankless system's 3-fold advantage in hot water delivery rate, better temperature control of propane-fired cooking, as 2 examples. First cost and ROI economics were also not covered. It should be mentioned that pod products, even the 97% efficient propane furnace, are widely available in the market and generally very affordable. Credits and incentives worth thousands of dollars can also be accrued for pod homes. In fact, PERC does have related research on both space heating systems and water heating systems that covers economics and ROI issues in great detail. Please visit billwithpropane.com to review those findings. For more information, check out these additional resources. Shown is a pod tool that allows you to more customized comparisons of pod versus standard homes. The tool outputs our annual energy cost, the HERS score, and CO2 emissions. You can find that at billwithpropane.com. Thank you for your time. This concludes the education unit. Please contact the Propane Education and Research Council with questions related to the information within this program.